Let's build the trigger sensor. If you haven't seen the sensor design video, I encourage you to check it out first. If you recall, the sensor is designed using an ESP8266 module, an ATtiny microcontroller, and a transistor. I have experimented with different layouts on PCBs, but we will focus today on the perf board layout. This is the one you can build at home. Ideally, you want to use the ESP12 module, but it's more difficult to solder, so let's use the ESP01 module instead. Let's start with the schematic. The ATtiny connects to the base of the transistor over PB3. The transistor collector connects to the ground of the ESP01, and this controls the power on and off for it. The emitter connects to the battery ground. Connect the two pins on the end of the reed switch to the battery, positive and negative ends, and connect the other end of the reed switch to PB1 on the ATtiny and RX on the ESP01. Usually, we need a done signal from the ESP01 to the ATtiny, but due to the limited number of pins on the ESP01, we will be omitting this. Instead, a timer is used to cut the power to the ESP01 after roughly 400 milliseconds. Make sure you get the three-legged reed switch. This eliminates the need for a pull-up resistor that would constantly drain the battery. Now the hardware is assembled, it's time to load the code. The code for the ATtiny can be found in this file, and the code for the ESP01 can be found in this file. The links are in the description below. Those are some of the values you might want to adjust, so I'm gonna go through the most frequent ones you might want to edit. For the ATtiny, there is the max time to keep the ESP8266 powered on. It's set to 300 milliseconds, but depending on your Wi-Fi connectivity, you might want to increase that a little bit. For the sender, you have define ESP12. Simply comment that to get the ESP1 module activated, or you leave it in if you're using the ESP12, but in our case, we're using ESP1. Also for the sender, there is the message sensor status, which use the switch pin and reads the value of that. So if you find that your sensor value is reversed, for example, it sends 1 when the door is open, you can reverse the value by desoldering the switch, or you can change that value in the code. Also for the sender, there is defined debug flag. You simply uncomment that if you want to read more debugging information. It makes your life easier when you're doing any troubleshooting. I will not go into a step-by-step on how to wire or upload the code for the ATtiny or the ESP01. Instead, I will link to some tutorial videos in the description from other YouTubers. Once the code is loaded, power it up using a LiPo battery. The device will start sending packages to the hub. And in the next video, I will show you how you can build a hub or the gateway. Also, in a future video, I will show you my second iteration of this sensor that uses an advanced LPO instead of transistor. It's safer and it's also more efficient, so stay tuned for that. And if you want to follow my journey, this is my Twitter handle. I often post there. So feel free to use the comment section if you need any help. Peace.